Hello, geometry. We are on lesson 11.7, surface area and volume of cones. So we've talked about this a little bit before already, and we know about the volume of cones because I included it with prisms and pyramids. So just so you're aware, I'm going to scoot this up a little bit. Volume of a cone is specifically when we have 1/3 pi r squared times h. Again, we know about this already. I'm hoping you guys are really liking this unit. This is typically one of students' favorite units because it kind of feels a little bit like algebra, right? There's some geometry in here, yeah, but for the most part, you have formulas and you're plugging in numbers and you're solving. And so I think a lot of students really like this unit for that reason. So we know how to do cones already. Let's do C right here really quick, just so we can remind ourselves. A quick reminder, I am at home, so you're probably going to hear some life happening in the background around me. Not a big deal, but just an FYI. We know volume is 1/3 pi r squared times h. Our h is right here, and this is our r, so v equals 1/3 pi times 10 squared times 8.4. When I plug that into my calculator, I get 879.65. You'll remember from a few lessons ago, I told you that you will want to round to the hundredths, and to always use the pi button on your calculator. Don't just abbreviate it with 3.14, right? Use the pi button and then round to 2 decimals. So surface area of a cone is right here. This part up here talks about how we get that. If you think about it, a cone has a circle for a base, and then its sides, if we were to squish them or flatten them out, are a circle with a piece missing, right? A circle with a piece missing. And so this is a major arc in this case, right? It's a major arc, and we can find that arc length and therefore the area of the sector. So that's really why we talked about 11.2, because this is a sector of a circle. So if I add the area of my base plus the area of this sector, that should give me the surface area of the cone. And that's all that this is right here. So let's actually plug that in and see what we get. We call this this side of the cone here the slant height, which is denoted with a cursive L. All right, so that's what this 6 is slant height. And then our radius here is 4. So we've got S is equal to pi r squared plus pi r slant height. So when I plug in my pi, r I know is a 4 squared, and then my slant height I said was 6. When I plug that into a calculator, because that's all you have to do, we find that the surface area, I do like to use SA for surface area, just a personal thing. The book uses all S, but I like SA. We plug that all in and we get 125.66 inches squared in this case. So try it with B, see what you get. Try B, see what you get. All right, you should have paused the video when you plugged in everything. Your surface area for this should have been 436.18 meters squared. The next thing I want to talk about is area and volume of similar solids. Now, we already know about the volume. We looked at that back in 11.5, I believe, where we had the volume of similar solids. In this case, area we have talked about before, but that was way, way, way back in chapter 8. So I want to remind us that if we take side length of a figure, figure 1, over the side length of a second figure, we get the scale factor k, right? That ratio is the scale factor k. If you square that scale factor, then it becomes equal to the ratio of the areas of the figure. If you cube that scale factor, it becomes equal to the volumes, the scale factor of the volumes. So it's kind of interesting because this k here, we know works for a perimeter of 1 over perimeter of 2. If we think about perimeter, all we're doing is adding them up, right? They're in a straight line. So it has exponent, it has an exponent of 1. With area, you have 2 dimensions going on, right? We have 2 dimensions going on. So it's got a scale factor of 2. And then for volume, we now have 3 dimensions going on. For those of you that have been reading the Flatland and having fun with that, which I hope you are, then we know we've got 3 dimensions. So I find it really interesting that we go from having an exponent of 1 with our scale factor for perimeters, to 2 with our scale factor for areas, to 3 with our scale factor for volumes. So just something to note. We're going to do both of these examples for E and for F. So for E here, we know that we have 9 for our big cone, divided by 3 for our little one, and that's a cube because it's volume. So I have the volume, which is 15 pi. Oh, I put that in the wrong spot. We are looking for the volume of cone B, so that's our unknown, and then we have 15 pi in our denominator. Sorry for the dyslexia kicking in there for a second. 9 divided by 3 we know is 3. And then we've got V over 15 pi. I'm going to cross multiply because this is really over 1, right? So we've got 15 pi. 3 cubed would be 27. And then we have just V. So that means the volume of our larger cone here, the volume of our larger cone, it would be 408 pi. 408 pi. So let's check out the area right now. Okay, let's check out the areas and see what we would get for that. We have the first side here is 10, and the second one is 5. Those are going to be squared. The area of our first figure is 36, and the area of our second we are trying to figure out. Well, 10 squared is 100 over 25, which is equal to 36 over A. So when I cross multiply that, I get 100A. 25 times 36 is something really big. Good news is I can just divide by 100, and I end up with an A that is equal to 144. And that would be centimeters squared. All right, for our next page, I want you to try these out. Okay, there are 6 problems on this side. I want you to try these out. Pause the video, see what you get. All right, for our first one here, we have to find the surface area of the cone. We have a right triangle right here. We know the base is 5, and we know that our height is 12. So to find the surface area, I can do 12 squared plus 5 squared is equal to something squared. When I solve for that something, you should have gotten 13. We plug that 13 in, you get 90 pi, which is equivalent to 282.74 inches squared in this case. Number 2, you should have gotten a volume of 667.06 inches cubed. For number 3, as I scoot the paper up, you should have gotten 200 thirds pi, which is equal to 209.44 meters cubed. For number 4, you should have gotten 6 pi centimeters cubed. 6 pi centimeters cubed. For number 5, you should have gotten 108. You should have gotten 108. And this would actually be feet squared, because it was all in feet. The next one, find the similar areas of the figure. The similar area should have been 6 centimeters squared. 6 centimeters squared. Remember, scale factor is unitless, all right? So they could have told us that this one was in meters and this one was in centimeters. It wouldn't have mattered. The area would have been in meters squared, okay? I know we talked about that a bit back in chapter 8, but it's been a while. Please email me if you have questions on any of this. Skills Practice is posted to Big Ideas.